This presentation speaks to an air cooling condenser, explains what it is and how it works. The condenser unit, direct expansion cooling, occurs when heat is removed from the airstream by the evaporator cooling coil. The cooling coil outlet suction line sensor, which senses the refrigerant discharge temperature, modulates the control valve on the inlet of the coil. This may be considered the heart of the dehumidifying system. This regulates the flow of refrigerant through the coil to maintain the desired discharge air temperature and humidity. On small systems, this control valve is controlled open or closed. On refrigerant coils, care must be taken in the setting of the refrigerant discharge air temperature so that the refrigerant discharge air temperature is limited to a low of 57 Fahrenheit, 15 centigrade. If it is not so, it is possible that moisture that condenses on the coil surface may freeze, and eventually the direct expansion cooling coil will become blocked with ice or at least frosted over. This can also happen if there is low airflow across the evaporator coil. Control theory states that a controller sensing zone temperature energizes an electric solenoid valve and a thermostatically self-operating expansion valve. These are located in the inlet to the piping for the AC condenser unit, direct expansion cooling coil. The solenoid is opened on a demand for cooling, and the thermostatic expansion valve regulates the amount of refrigerant that passes through the coil. The vaporized refrigerant in the tubes of the DX expansion cooling coil absorbs heat, which is transferred from the air passing over the coil tubes. The thermostatic expansion valve is located in the refrigerant line to the cooling coil. The compressor operates while the thermostatic valve allows refrigerant into the cooling coil. When the desired coil temperature is reached, the TXV throttles the flow of refrigerant to assure that only gaseous refrigerant leaves the cooling coil outlet and moves on to the suction side of the compressor. When the refrigerant demand is satisfied, the solenoid valve closes. As the compressor keeps reducing the pressure on the suction line, a constant pressure is reached, which turns off power to the motor automatically. On a large AC unit system, it is necessary to control the compressor discharge in states to match the loads and prevent cycling of the compressor motor. The sensor control of the unloading of the cylinders can be based on suction pressure of the unit, temperature of the return air, or temperature of the occupied space. A packaged AC condenser unit. The AC condenser unit provides refrigerant flow to the remote evaporator direct expansion coil located in the air system. It is usually meant to be operated during summer months only, but when called for, winter operating packages are available. The sequence of operation for the condenser unit. The unit operates automatically when the compressor started switch is in the on position. The condenser air conditioner switch is in the on position. Outdoor air temperature is above 55 Fahrenheit, 14 centigrade. The air system is on. The cooling coil discharge air temperature is above set point. or on a demand for cooling, this sequence occurs. Control relay energizes the solenoid valve at the DX coil. Evaporation of refrigerant in the coil starts to raise the pressure on the suction side of the machine, which energizes the control relay at the condensing unit control panel. The control relay for the compressor and related control circuits is energized. The control relay for the condensing unit fan control circuit is energized. The thermostatic expansion valve, TXV, is located in the refrigerant line to the cooling coil. The compressor operates while the thermostatic expansion valves allows refrigerant into the cooling coil. When the desired oil coil temperature is reached, the TXV throttles the flow of refrigerant to assure that only gaseous refrigerant leaves the cooling outlet and moves to the suction side of the compressor. When the refrigerant demand is satisfied, the solenoid valve closes, and as the compressor keeps reducing the pressure on the suction line, a constant pressure is reached, which turns off the power to the motors automatically. Thank you very much for listening.